Later on in this video, we're going to understand what is a grid trading on a basic level. I'm going to explain from a manual trading perspective a grid trading system and see the examples of how such strategies work. Then later on, we're going to implement a simple trading bot using Python and MetaTrader 5, backtest it, and see the outcome. We'll discuss different tactics to improve your grid trading system, including using Martingale money management for tackling the challenge of drawdown that comes with grid trading systems. And finally, we're going to use the optimization framework to get the best parameters out of this trading strategy. This way you can end up with the best trading robot for your trading usage. Make sure you don't skip any chapter because the information dropped in this tutorial is one of a kind and very useful for algorithmic traders looking to build their own trading systems using Python and the most powerful trading platform MetaTrader 5. Before we proceed, I just want to say that all the code files and examples used in this tutorial will be linked down in the description below. And if you find this video useful, feel free to like, share, and subscribe to the channel for more content like this. I'd also like to invite you to my Telegram and Discord communities for like-minded traders, where we share ideas on algorithmic trading and investing in general. So without further ado, let's dive in. Let's understand what is grid trading on a basic level. As the name suggests, grid trading involves placing multiple buy and sell orders at a fixed price interval, creating a visual horizontal grid of trades on the chart. These intervals are what is called grid gaps. Traders can define the grid gap based on how volatile the instrument is. Once the grid is set up, it reduces the need for frequent manual intervention. The system automatically triggers trades as price moves through each grid level. As you can see from the image, suppose this is the market. These imaginary lines represent region in the market. Then at some point we're having buy trades placed, and at the same time we're having sell trades in the exact same points. The purpose of grid trading is to benefit from the market in either direction. A typical grid trading system doesn't have a stop loss. No matter what happens, all the losing trades will be kept open until they turn into profitable ones. Now, there are different ways to trade or to implement your grid trading strategy. Some traders prefer to set pending orders in all these regions in the market, but in this tutorial I'm gonna teach you the simplest yet effective grid trading method that I've personally used in the past and helped me generate a few $100. Say this is the market. This is the highest price. Meanwhile, this is the lowest price. We could say if the market goes below this highest price by 100 points, usually referred to as grid. So if our grid gap is set to 100, then we could say if the market goes below this highest price by 100 points, we open a buy trade. As the market keeps on going down, we repeat the same thing by opening another buy trade. Since this is a downtrend, we expect the market will go back to the highest price somewhere in the future, or the prices will retrace to their main values. So by opening buy trades as the market keeps on descending, we are hoping to capitalize on these price fluctuations that could occur during this downtrend session. This was for long trades or buy trades. Now when it comes to short trades, we do the opposite. Say this is the market going down. This is the highest price. while this is the lowest price. If the market retraces back from this lowest point, if it goes upwards by 100 points, which are the grid points described, we open a sell trade. As the market keeps on going upward, we keep on opening sell trades as long as the grid condition is reached. So initially we use the lowest price as the lowest point to start grid trading, but as we keep opening positions, the lowest point becomes the previous sell trade opening price. So in doing so, we end up with a trading strategy that opens the grid in either direction. So while others are using pending orders, this is my favorite way of trading a grid-based trading strategy. Now let's dive in our text editor and implement this trading logic using Python and MetaTrader 5. So in your PC, go to your desired location and create a new folder. Let's give it the name Grid Trading Project. Open this folder in your desired text editor. For this video, I'm gonna use PyCharm as my text editor. So from your projects folder in the text editor, open the command prompt. Let's create a Python virtual environment that will be used for keeping track of all dependencies and the Python version used in this project. With the Python virtual environment created, activate it from your command prompt. With it activated, let's clear the screen. From projects folder, create a Python file. We will implement all of our trading ideas inside. So let's give it the name grid_bat.py. Press enter to continue. And this will create a Python file. We need some dependencies. Since we want our trading robot to operate on the MetaTrader 5 platform, we should install MetaTrader 5. We should also install Strategy Tester 5 as our backtesting framework. Press enter to install these dependencies. After installing all the necessary dependencies, you want to make sure that your IDE recognizes your newly created virtual environment and it references from that particular folder. In our case, it is the one starting with .vmv from the same projects folder. Let's start by importing this module. After importing MetaTrader 5 as empty file, we should initialize the MetaTrader 5 platform. And since this is a crucial process, we should check if the initialization process was a success. If it wasn't successful, we should return and raise a runtime error that prevents the bot from further executing. Then lastly, we should shut down the connection between this Python script and the MetaTrader 5 API. Now, for our trading strategy, we need a few global variables, which include the instrument we want to operate on, labeled as symbol. Let's give it the name EURUSD. We also need the time frame we want to operate on. In this case, let's operate on the 1 hour time frame. And we need the magic number, which is the unique identifier for this particular trading robot. Give it any value, in this case 1 up to 5. Let's define a main function, which is the main function all the trading operations will take place. This is where we want to implement the trading logic. Okay, since our trading strategy relies on identifying the highest and lowest prices in a particular window, The first thing we need to do is to get the highest and lowest prices for a particular window. Notice that I've said the word window. This is because the highest price in the market at some point could be the lowest point in another region of the market. So the window is very crucial. And that being said, we should define a variable for this window, grid_window. Let's give it the value of 48. The reason for this particular number is 48 represents 48 hours, since this is a 1 hour time frame. So we will be searching for the highest and lowest values within 48 hour period. Now with that in mind, we know that highest and lowest price comes from bar information. So we should obtain bars from the MetaTrader 5 platform. From those obtained bars, we should search for the highest high and the lowest low of a particular window. So this means we should obtain rates using the function code copy_rates_from. So from the MetaTrader 5 API, use the method copy_rates_from_POS. It expects the symbol, so we pass it this instrument and a time frame, a starting position. In this case, we want to start at the index of 0, which is the current bar in the market. For the count or the number of bars we want to get starting from this start position is when the grid_window value comes into play. We should assign the obtained object to a rates variable. Then we should convert the rates, which is a NumPy structured array, into a pandas data frame, which is human readable. Since we want to convert this into a data frame, which is a pandas object, we should go ahead and import pandas. From the pandas module, get the data frame class and assign it to the rates object. And this will successfully convert NumPy structured array into a pandas data frame. Now, as I said in the previous video, it is a good practice to copy bar information only if there's a new bar emerging in the market. Since this is a 1 hour time frame, you only want to copy bar information from the terminal if a new bar has just emerged in the market. Since this is a 1 hour time frame, new bars will be at the exact hour. To understand this in detail, let's implement the function for checking if there's a new bar. Give it the name is_new_bar. It should have the time frame as an integer. Use the time frame value as a default value, and it should have the current time in seconds. This should be an integer. Since we are getting current time in seconds, we should divide the current time in seconds with the current time frame value, which is an integer in seconds as well. We should convert the current time frame into seconds. So essentially identifying the number of seconds in a 1 hour period and dividing that value to the current time in seconds. The remainder of that operation should be 0. Indicating that there's a new bar at the market. Otherwise, that indicates that we're in the middle of the hour. So define a variable called timeframe_seconds. While you could obtain the 1 hour time frame value in terms of seconds online, go from the strategy tester module and import the function for doing automatic conversion. So from strategy tester 5, go to the MQ5 submodule. From the functions, import the function. Call this function here. It has the syntax similar to that of MQ5, so these capital letters doesn't mean a function is a class. So we pass the time frame, then return if the remainder of current time seconds equals to 0, then this represents a new bar. rather than defining the rates object and extracting this information from the MetaTrader 5 platform, let's define the value as a global variable. So it should be here, rates underscore df. Could be a pandas data frame, so leave it the type of pandas data frame. Then we should only copy bars information from the MetaTrader 5 if there's a new bar. Now when it comes to current time in seconds, we don't have a way to access the time yet, and we cannot use the local time because it might be different from the current time in the MetaTrader 5 broker server. So define a variable before all this code ticks. From the MetaTrader 5 API, use the method called symbol underscore info underscore tick. It expects the instrument, and this should give the current tick values from the terminal. Then from the ticks object, you can extract the time. So ticks.time will give you the current time in seconds. I mean, this is wrong. This will not retain its value. Assign the rates data frame object as none. Assign it as a dictionary. Oh, let's give it the name rates cache. Then after defining the rates data frame, we go to the rates cache. Assign this data frame. And this will successfully retain its value until modified throughout this main function run. And this will become very important later on as we try to optimize this grid-based trading robot. Then after obtaining the rates, because anything can happen from the MetaTrader 5 API call, and this could fail due to several reasons, so we should check if the function was a failure. If we did not receive the rates object we desire, we should return and prevent the function from further executing. So we can say if rates underscore df is none, this should return. This should be rates hash, and then we can say df. If the obtained value from this is none, or let's just say rates underscore df equals to rates cache df, then we shouldn't define this over and over again. Just assign the data frame object to the dictionary directory. Okay, then we can say if the rates data frame is none, or we can measure the length of this object to ensure that if it is less than what we anticipated for, which is it should be equal to the grid window, since this is the number of bars we want to obtain from the terminal, return and prevent further execution. That being said, let's implement our trading logic, which goes like, if the current price is below the highest price by a certain value, which is the grid gap, this is a bullish signal, as we've seen from this illustration. So for long trades, we measure the current price from the highest price using the grid value. That means we should define the grid value as a global variable. Now, it is a best practice. Rather than using these global variables, we should only use global variables for values that do not change. For example, the instrument and the time frame, these are the values that do not change. But for values like the grid window, this should be as the arguments for the main function. Pass the default value, then use it throughout the function. And this is the best practice. As I said, we need a grid gap. This should be an integer. Let's set the default value to 100 because I'm sure Euro USD doesn't move in a lot of points. Now we should get the current price. We know the current price isn't a single point in the market. It can either be the ask price for buy trades or the bid price for sell trades. But let's use it universally. Let's say current price equals to ticks.ask. Let's just use the ask price for checking on both signals. Then we can say if the current price is below the highest point in the market, then we should obtain the highest and lowest values. Define a variable called highest high. Then from the rates data frame, go to a column called high. Let's import numpy. Just below pandas, import numpy as np. Then call the method np.max, which return the maximum value from the column called high. Then we need the lowest low, which should be the minimum value from the low column. Then we can say if the current price is below the highest high point in the market minus some grid point or the grid gap. Now the grid gap, let's specify it as points because these are 100 points and not pips. Some traders prefer to use the 10 pips, but I do prefer to use points as they are straightforward. Now this is just a value we just inserted. If you want to convert this value into some value accepted in the market, then you should multiply it to something called points. These points differ from one instrument to another, and they are responsible for converting any value you randomly have in mind to some value in the market. So what you want to do is go to the symbol information because each instrument can have different points. So from the main function, let's introduce another variable. Call it symbol_info. Let's set it the value of none for now. From the symbol info object, define a variable called PTS, which represents points. So from the symbol info object, get the variable called point. Now don't worry about the syntax warning because this symbol info is a non-object for now. So accessing the attribute called point will always be invalid. So multiply it by this PTS value. Now if this happens, then we want to open a buy trade. Now to send some trading commands to the MetaTrader 5, we need to import another class from the strategy tester module. So from strategy tester 5.trade classes, you want to go to the trade submodule and import the ctrade class from there. Now this is supposed to be instantiated just before the global variables, which do not change. Define a variable called mtrade and assign it to the ctrade class object. When you hover over this, you can see it expects the magic number as a named argument, so we give it the magic number. It also expects something called filling_type_symbol, which should be an instrument you want to operate on. The class also expects the terminal. It's the active MetaTrader 5 instance, which is the initialized one. In this case, it is the MT5 object. It also expects something called the deviation_points. This represents slippage. So we define a global variable called slippage, give it the value of 100 and pass it here. With the mtrade instantiated, we can then use it to send trading commands. So from the mtrade object, call the method called buy. This will trigger a buy trade in the MetaTrader 5 platform. It expects volume, which is the trading lot size. Then we should define a volume here. Let's give it the value of 0.01. Now this might vary to different instruments. Pass the value here. It also expects the price, the entry price. Since this is the buy trade or a buy order, we should enter it at the ask price. So from the ticks object, get the ask property. Now, as I said in the diagram, a typical grid trading system doesn't have a stop loss. So all the losing trades will be kept open until they get closed with a take profit hit. That being said, we don't need to fill the stop loss value, but for TP, which stands for take profit, we can then set from the entry price, which is the ask price in this case, ticks.ask, you want to set the take profit from the current entry price to some grid value above In this case, it will be at the highest price because this is the very first position in a grid sequence. So ask price, grid gap in points, then we have to multiply it by PTS again. We do the opposite for a sell trade, where we check if the current price is above the lowest low, plus some grid gap in points. This is a sell signal. And if it's a short signal, what we should do is open a sell trade. For the price, we set it to ticks that bid. Then for the take profit, we set the value from the entry price, which is the bid price, minus the grid gap in points multiplied to PTS value. Now we are missing the instrument. This buy and sell methods expects the symbol you want to operate on. So we can say symbol equals to, we pass the global variable for an instrument. And that's it. This will trigger our very first trade. However, it won't open additional grid trades. As I said in the diagram, if a grid position exists in either direction, then next trade in the sequence will use the previous entry price as its lowest or the highest price for sell and buy trades respectively. So what we should do is to modify these highest and lowest values. So we could say if there's a prior position in the grid, I'd prefer to count them. So we can say if total buys in this case equals to 0, then the highest high should be the last position's open price. And since we don't have a function for counting buys or sells, let's go ahead and define a function for the task. Just before the main function, define a function called count_positions. So we should count the positions based on their position type. This way we don't conflict between buys and sells. Or we can just say type as an integer. Then we can check if the position has the same magic number as this current trading system, because you do not want to count positions triggered by other trading systems in the terminal. Optionally, we can assign it as the global variable. Okay. It should be an integer. Okay. And last but not least, we should check if this position is opened in the instrument we're working with. Then define a variable called count. Set the initial value to 0. Go to the MetaTrader 5 platform and get all positions. After obtaining all those positions, we should check if at least a single position is returned. Then we can loop through all those returned positions. So by looping through those positions, we can check if a position type equals to the type we specified and it has the same symbol, has the same magic number as the one passed in the function. If that happens, we count that position. Finally, we return the number of positions counted. Now, just for syntax purposes, return the integer value. Then, before this if statement, you can define a variable called total buys, total_buys. Call the function count positions, give it the position type. So from the MetaTrader 5 API, go to positions_type_buy. This time for position_type_sell. And this should be total sales. Now, the thing is, it's a good practice to prevent referring to global variables as much as possible. For example, you can see in this function, we are referencing to the MT5 object, which is outside this main function. Later on, as we try to optimize, this can become conflicting. It is best if you introduce this MT5 object as an argument for this main function. So we can say which MT5 Just choose a unique name that differentiates it from the MT5 object outside it. Replace all the existence of MT5 in the function with this. For IntelliSense support, from typing, import any and optional, just in case we might need these. Here we can say after obtaining the total number of buys and sells, we can say if total buys equal to 0, if this is the first time opening grid trade, then the highest price should be the exact high value. And since the lowest low is used for sell trades, then we can say if total sales equals to 0, then the lowest low should be the actual lowest low. Otherwise, if there has been a trade before, then we could say the highest high should be the last buy position opening price. Now we don't have a way to access the last buy position information, so let's define a function for the task. It's all about functions. Then we can say last underscore buy. Now I've just said about making sure you don't refer to the MT5 object which is outside, and as you can see we've accessed it here in the function, so we have to make the changes here as well and refer to the new object to the function argument. We'll do that in a second. For now, let's go ahead and import the properties, the unique properties we want to distinguish for the last position we want to obtain from the MetaTrader 5. Then we repeat the first thing we did in the function for counting positions, obtaining all the positions from the terminal. Then if at least a single position is returned up through all these positions, we check if the properties resemble the ones we specify in the function, this time with one additional check. To identify the latest buy position, we should identify its time. So let's define time, call it position underscore time, and set it to value of -1, which is the minimum value. Then we can say if position.time is greater than previously stored position time, then this is the latest position. Define another variable called last position, set it to none. So last position becomes the current position and the last time becomes the current position time. So finally, we return the last position. Now it's time that we change this to which MT5. We introduce the variable which MT5. Replace the existence of MT5 in the function with which MT5. Do the same here. And that's it. This should return last position properties. So what we have to do is introduce the variable called last buy, and from the last position function, did we call it last position? Oh, we called it as last buy, which is wrong. It should be last underscore position. So from the function last position, pass the position type by constant from the MetaTrader 5 object. We do the same but opposite for the last cell. With that in mind, go to the last buy and get the property called price open. This returns last position's opening price. And we do the same for when a sell trade exists. We say the lowest low equals to last sell price open. Adding this condition will single-handedly fix the issue of grids. The first time we will use the highest price, and the second time and fourth we will use the previous opening prices. Now, if you were to run this in real time or use this trading robot for trading in the live account in the MetaTrader 5 terminal, just create an infinite loop and call a main method with the properties you specify. For which MT5 this time we specify the actual MT5 object, the rates hash object, we can just define it right away. Define it as a dictionary, df for pandas data frame. Now this should be a string. Then pass the rates cache here as the symbol information object for symbol info. This time we go to the MetaTrader 5 API and call the method called symbol_info. We pass it the instrument. Okay, we're getting a warning here which says expects none. Okay, this is because we are passing none here. We could just pass the dictionary. And for symbol info, we can just say any. This should take any object, whatever it is that the MetaTrader 5 symbol information object provides us. Then if that's the case, we should check if the symbol information is not none, because the API can fail. And as you can see here, this is an API call. So the first thing we should do in this main function, we can check if symbol_info is none. Return. Another thing is the grid window and the grid gap endpoints, which are loaded by default. Okay, we're having some error which says okay, it expected a colon here. Some warnings here, but that's fine for now. So yeah, this infinite loop will keep on running this function and monitoring the market. And the rates hash should be outside, my bad. This way it will return the value over multiple iteration of this infinite loop. Now for backtesting, select each and everything in this, pressing Ctrl+C, then create a new file, give it the name grid_bat_backtest.py. Paste each and everything here. Then you have to make a few changes to this code so that it can be backtestable. First thing you have to do is go from the strategy tester. Go from the strategy tester 5 framework. From there, go to the tester submodule and import the strategy tester class. After global variables and initializing the MetaTrader 5, you want to instantiate the strategy tester class. Assign it to a variable called tester and call the class. This expects a tester config, which is a dictionary that you can refer by going to strategytester5.com. From there, go to documentation. Getting started. From the quick start guide, you will see how the tester configurations are supposed to be. This resembles the MetaTrader 5 strategy tester configuration. If we open the strategy tester in the MetaTrader 5 platform, if you can see this, go to view and make sure strategy tester is selected. So I'm gonna copy this code and paste it in my project just before the class, defined as a variable called tester configs. Then paste it. Delete the previous curly bracket since this was a JSON. Change the bot name. This is grid. For the instrument, rather than using a hard-coded instrument, use This should be an array. Just use the current symbol. Since this is 1 hour time frame, this is okay. Set to H1 as the 1 hour time frame. So let's backtest from January of this year all the way to the 1st of May. For the modeling type, I'm going to leave it to default, which is the 1 minute or HLC values, and we're going to go with the 1000 deposit of the currency present in the MetaTrader 5 account. The leverage, I prefer $100 for every $1 we deposit. Call the named argument called tester config and assign it to tester configs dictionary we just created. This also expects empty5 underscore instance, which is the initialized MetaTrader 5 instance. So we pass the empty5 object. The rest of the arguments to this class are optional, which includes the logging level, folders, and so on. So that's all you need for now. Then, and this is very crucial, you have to extract the MetaTrader 5, a simulated one, from this tester object. Go to the tester object and get the property called simulated underscore empty5. So for all the existence afterward, you are not going to use empty5 because we now have a new simulated one that will run the backtest in a simulated environment. So copy the simulated empty5 and replace all the existence of empty5. Now this is when introducing empty5 as an argument throughout all the functions becomes crucial, because now what we have to do is assign the simulated MetaTrader 5 when calling the main function. I forgot to assign the value for which empty5. The second argument is type. I prefer using named argument. They are less error prone than just passing the arguments. Okay, now we don't need to modify anything. When asked for which empty5, we'll pass the simulated MetaTrader 5 here forth. Now, this was coming from if you want to run this in real time. Delete the infinite loop. This time you call from the tester object a function called run and give it to run this main function. Now the main function has arguments, and that might produce a syntax error, so we can pass it as a lambda function. This should work like a charm. Or define it as a variable for the lambda function. Let's call it strategy. And that will work just fine. So when calling tester run, call the function strategy. Let's check if we have some errors. Okay, we're just having some warnings for the unused statements. Nothing to worry for now. It says shadows build name type. Okay, so let's just change the type. Let's change it to position POS underscore type and replace the existence of type with it. Also defined it here. If it's hard to follow along with my coding progress, you can find these files in the description below. Okay, let's try now. So we've initialized the data frame object, so let's set it as none, because this will help us catch when the data frame was none the first time this function is running. And another silly mistake is I'm using the empty5 rather than the simulated MetaTrader 5 as I've just instructed. Clear the screen. And there you go, you can see we're getting verbals on positions getting opened in the simulated environment. Let's give it a few seconds for the backtesting to complete. Nice. Now we can go to reports to find a strategy tester report, which should tell us what happened during a backtesting period. And there you go. We made the total of 1,749 trades. The winning accuracy was decent at the 97 winners. This is expected because we don't have stop losses, so we're gonna keep on holding those positions until they get closed. Now these are smooth, balanced, and equity curves. If you want to see the real ones, we have to toggle these two and go to the raw balance and raw equity. And this tells us the actual story of what happened in the simulated market. And as you can see here, in the end, all the positions got closed, and that's why we had this dip, which took the account balance to the same value as the equity. Nice. You can analyze the trades, but there's no way to visualize to see if the strategy was firing exactly as you wanted to. The free version doesn't provide a way to visualize your trades as they happen, but the premium version offers this capability by visualizing your trades in the MetaTrader 5 strategy tester platform. And later on, we'll see how you can introduce the Martingale lot sizing. Right now, I have installed the strategy tester free version. Uninstall it and install the premium version, which shouldn't affect the performance. No major changes are required to be made. So I'm gonna do pip uninstall strategy tester 5. So from the premium repository, for those who purchased this, go to the releases section and download the latest wheel. Navigate to your downloads folder and copy it as path. With its path copied to the clipboard, I'm gonna go ahead and do pip install and paste that particular path. Press enter to install it, and this should take a second. So after installing the strategy tester 5 premium version, you have to make a single change to the tester config by introducing something called visual_mode. Set the value to true. And there you go. Let's run this project. It's the same as the free version. And when backtesting is done, this will open the MetaTrader 5 platform and simulate your trades from there. There you go. You can see the grid positions as they were happening in the market. So finally, the graph looks similar to the one we had in the strategy tester 5 report. If you notice, the backtesting report should look similar as well. Now the thing is, we've made losses in the MetaTrader 5 strategy tester, and this is why backtesting in the actual MetaTrader 5 terminal becomes important. Grid trading systems are not for each and every instrument. If your strategy doesn't work, doesn't necessarily mean it's bad. It could be that you're operating on the wrong instrument. Not all instruments are suitable for grid trading. Traders usually trade such strategies on ranging markets. I found success with such strategies in one-directional markets such as the Nasdaq index or the S&P 500. Let me show you what I mean by this. So this is the US 500. And if you zoom out to the chart, or you can see the upper time frame such as the 4-hour time frame, you can see it is always going upward. With this strategy that opens short trades as the market keeps on going upward and does the opposite as the market is on a downtrend, we can capitalize on those retracements that happens on a regular in such volatile markets. Now the key is to have some sort of stop loss which could be wider than the take profit, because some trades will eventually end up in losses. So to prevent huge equity drawdowns, the stop loss will become crucial, or some sort of money management and risk settings. Now if we go to the illustration we had earlier on, say at some point where we had the very first sell trade here. This is the first sell trade. Then for the third sell trade and the second, the equity drawdown becomes larger than when there were a single trade. On the second trade, the equity drawdown is multiplied by the factor of 2. And for the third trade, it is multiplied even further by 2 raised to the power of 2. So to combat and offset these losses, traders often rely to the Martingale money management for their grid trading strategies. Now Martingale looks like this. For the first trade, we used the initial lot size, which was 0.01. For the second trade, we'll open at the lot size of 0.02. Then for the third trade, the lot size will be equal to 0.04. Now notice that the lot size keep on increasing exponentially as the equity keeps on going down. This is dictated by the so-called lot size multiplier. If our lot size multiplier was equal to 2, then the initial lot size was 0.01. For the next trade after it, we use the previous lot size multiplied to lot size multiplier. We do the same thing for the third trade by multiplying the previous lot size by the so-called lot size multiplier. So let's introduce Martingale lot sizing. Given that we have a function for obtaining last position's property, we can obtain a last volume from there. So before opening a buy trade, we can say in this if statement, define volume before here, set it to 0. Then we can say if there were 0 trades, then we are going to rely to the initial volume, which is 0.01. So no change is made here. But if we have at least a 1 buy position, the current volume becomes last buy's volume multiplied by the lot multiplier factor. So we should define it here. Then we can say lot multiplier. This should be an integer, or you can set it as a float, set it to 2. So last buy volume multiplied by lot size multiplier. We do the same if there were at least a single sell trade. Now it might be effective to specify the volume for each position type, because the final volume doesn't care if the previous volume was coming from a buy or a sell trade. In a situation where you could have several trades on different directions. So we can say buy volume, let's be specific. And we can say buy volume. Then for the volume, we can use their respective volumes we just defined. Delete the previous volume declaration, and let's try running this. Now for premium users, once you run the backtest, the thread will keep MetaTrader 5 pending, so you have to close it manually. Okay, once it gets released, run this. This is wrong. This shouldn't be last buy, this should be last underscore sell, since this is a sell if statement. Then finally Okay, we made far greater losses. Again, this strategy doesn't work on every symbol. So let's try this on another instrument. In this case, let's try it on S&P 500, which is labeled as US 500 in my broker. Now, if you run this with the previous values, as we've seen that this particular trading strategy relies on preset values such as grid window, the lot multiplier, and the price gap in points. You have to find the optimal values for each one of these because the entire strategy depends on how accurate these particular values are. We could have the wrong grid gap in points. For example, the default value is 100, and as we know, the S&P 500 moves in a lot of points. If we try to measure just a simple region in the market by using the cursor tool in MetaTrader 5, you can see just this wave alone was equivalent to 11,200 points. So that means our grid value of 100 isn't gonna work. And this brings me to optimizing your trading strategies. However, this video is nearly 1 hour. It's already long enough. There is another video for optimizing this particular trading system displayed on your screen shortly. And that's it. Thanks for watching.